So, guys, welcome to the Agentic AI course. Here we will learn about how to create agentic AI systems step by step. But before that, let's look into some demos which will show the capabilities of the system which we are going to build in this course. I want to demonstrate three key capabilities that make this agent truly powerful: mathematical problem solving with tool integration, budget planning with memory retention, and web search capabilities. But here's the really impressive part: it remembers everything we discuss and can use multiple tools seamlessly. Let me show you what I mean through three live demonstrations where you'll see how it calls tools and uses memory for each scenario. Here I'm giving a prompt asking it to calculate compound interest with specific values. Notice that it starts the calculation and processes the mathematical formula correctly. Next prompt, I'm going to ask what principal amount I mentioned, and you'll notice that it returns me the same value. This means our agent is capable of remembering what I said, which normal chatbots don't have. Now let's look at the second example. Here I'm giving a more complex prompt, asking it to plan a budget with a specific income and percentages, and also to search for budgeting tips. Notice how it coordinates multiple tools. First, it performs the calculations, and then it searches the web for additional information. You'll see that it has returned the details along with 5 reference links to help manage a student budget. This is really impressive. Now, let's move on to the memory test. In the next prompt, I ask, what was my monthly income that I told you about? You'll notice that it correctly returns the same value, $4,500, along with the context. This demonstrates that our agent has perfect memory retention. For the third example, I'm asking it to search for the latest developments in AI agents in 2025. Notice how it uses the web search tool to get current information beyond its training data and provides comprehensive results. You'll also see that it has returned 5 reference links. Now, let's do the memory test again for this example. I ask, what topic did I ask you to search for in my previous message? You'll notice that it remembers the exact search query, the latest developments in AI agents in 2025, along with the information it found. This shows perfect memory retention across the entire conversation. Now let's look into the topics what we are going to cover to build this system in a step-by-step manner. So guys, we've already seen some exciting demos of our agentic AI system. Now let's take a step forward and dive into the core topics of this journey. This is going to be an incredible hands-on experience where we'll build something truly mind-blowing, a fully functional personal assistant agent that can think, reason, and act like a human, but powered by AI. This isn't just another coding course where you copy paste examples. No, this is where you step into the role of an AI engineer, understanding every line of code, every architectural decision, and most importantly, walking away with a working AI agent that you built yourself. How amazing is that? We'll be diving deep into the React pattern, a cutting edge approach that's transforming how AI agents operate. By the time we're done, you'll have created an agent that doesn't just answer questions, but also takes actions, uses tools, searches the web, manages memory, and solves complex multi step problems like a true digital assistant. First, we are going to work on establishing our development environment properly. Virtual environments are crucial for Python projects because they prevent dependency conflicts by creating isolated Python installations for each project. When you work on multiple Python projects, they might require different versions of the same package. Without virtual environments, installing a new version for one project could break another project that depends on an older version. We will create an isolated environment for the personal assistant agent project. You will understand why global package installation can break other projects and learn the best practices for Python environment management. Next, we will work on creating a requirements.txt file that lists all the essential packages our agent needs: OpenAI for LLM communication, Python.env for secure configuration management, requests for web interactions, and rich for beautiful CLI output. Each dependency serves a specific purpose in our architecture. The OpenAI package provides direct access to GPT models and handles the complex API communication. Python.env manages environment variables securely, keeping sensitive API keys out of your source code. The requests library enables HTTP communication for web searches and API calls. The rich library creates beautiful formatted CLI output with colors, tables, and progress indicators that make our agent interface professional and user-friendly. Requirements.txt ensures project reproducibility across different machines, and will implement version pinning for stable deployments. We will work on setting up environment variables to handle sensitive information like API keys securely. Configuration management is critical because hard coding API keys directly in source code creates serious security risks. If you commit API keys to version control, they become visible to anyone with access to your repository, potentially leading to unauthorized API usage and security breaches. Environment variables provide a secure way to pass configuration data to applications without embedding them in code. The die-env file approach allows developers to store configuration locally while keeping production secrets in secure environment variable systems. After that, we will work on creating a config class that validates all required settings at startup, preventing runtime failures due to missing configuration. This validation approach follows the fail fast principle. It's better to catch configuration problems immediately when the application starts rather than discovering them during critical operations. We will implement centralized configuration management for different environments, ensuring that our agent can be deployed across development, testing, and production environments with proper security measures. Then we will work on implementing a comprehensive logging system that will be our window into what the agent is thinking and doing. Logging is essential for debugging AI systems because agents make complex decisions through multiple reasoning steps. And without proper logging, it's nearly impossible to understand why an agent behaved a certain way or where problems occurred. Structured logging means using consistent formats, timestamps, and contextual information that makes logs searchable and analyzable. We will format logs consistently, output them to both console and files, and implement log rotation to prevent disk space issues. We will work on creating structured logs with different severity levels. Debug level captures detailed troubleshooting information, including internal state changes and decision points. Info level tracks general operation flow like tool calls, user interactions, and major system events. Warning level identifies potential issues that don't break functionality but might indicate problems. Error level records serious problems that prevent normal operation. This logging system becomes invaluable during development and production for understanding agent behavior and troubleshooting issues. Next, we will work on memory. Conversation memory is fundamentally different from simple chat history storage. In agentic AI systems, memory serves as the contextual foundation that enables coherent multi-turn interactions where the agent remembers not just what was said, but what actions were taken, what results were obtained, and what context has been established. Memory is required for coherent interactions because language models are stateless. They don't inherently remember previous conversations. Without proper memory management, each user message would be treated as a completely new interaction, forcing users to repeatedly provide context and making it impossible to build upon previous conversations or maintain ongoing relationships with the agent. We will build a conversation memory class that manages the complete history of user interactions, system messages, and tool execution results. This isn't just storing chat messages, it's maintaining a rich contextual database that includes message roles, user, assistant, system, tool, timestamps, metadata, and persistent context that spans multiple sessions. Finally, for this module, we will work on implementing intelligent memory management that handles context preservation, memory limit enforcement, and smart trimming strategies. Memory limits are necessary because language models have token limits, and unlimited memory growth would eventually break the system. Smart trimming means preserving important information like system instructions and recent context while removing less critical historical data when memory limits are reached. This enables natural, contextual conversations and relationship building while managing the technical constraints of language model, token limits, and system resources. We will work on creating the foundation for unlimited extensibility, the base tool interface. Standardization allows our agent brain to work with any tool without needing custom code for each one. We will design an abstract base class that defines the contract all tools must follow, enabling unlimited extensibility through consistent interfaces. This abstraction is what allows us to add new capabilities to our agent simply by creating new tool classes that follow the established pattern. Next, we will work on implementing JSON schemas that describe tool parameters for LLM function calling. That daemon schema method returns parameter definitions and requirements, while the execute method performs actual tool functionality with standardized returns. JSON schemas are critical for reliable tool calling because the LLM uses this information to generate properly formatted function calls. Clear and comprehensive schemas reduce errors and improve the reliability of tool interactions. We will work on implementing our first concrete tool, the calculator, with a focus on security. Using eval is extremely dangerous because it allows arbitrary code execution. We will learn how abstract syntax tree parsing provides a secure alternative that gives us the functionality we need while maintaining security. This security first mindset is essential for building trustworthy AI systems that can be deployed in production environments. After that, we will work on creating a whitelist of safe mathematical operations, add, sub, mount, div, bow, and implementing logic that rejects any operations not on the approved list. This demonstrates safe code execution patterns for production use and shows how to balance functionality with security requirements. The AST parsing approach ensures that only mathematical expressions can be evaluated. Nothing dangerous can be executed. We will work on building the web search tool that extends our agent's knowledge beyond its training data cutoff. This involves implementing HTTP request handling with proper error management and networked timeout and retry strategies for reliability. This tool demonstrates how agentic AI systems connect to the broader digital world to access current information that wasn't available during model training. Next, we will work on implementing API authentication and secure credential handling. We will also build response processing that converts API responses into formats our agent can understand and work with. This connects our agents to external services and teaches you how to handle real-time data integration in a secure and reliable way. We will work on implementing a comprehensive tool result system that standardizes how all tools communicate their outcomes. The tool result object provides a consistent format with success status, data payload, error messages, and optional metadata. This standardization ensures that our agent brain can handle results from any tool in a predictable way, making error handling robust and enabling consistent user experiences. Finally, we will work on implementing robust error handling with user friendly feedback throughout the tool system. This enables consistent user experiences across all tools and provides the foundation for reliable multi tool coordination. Good error handling translates technical problems into actionable user feedback and maintains system reliability even when individual tools encounter problems. We will work on crafting system prompts that define our agent's personality and behavior. System prompts serve as the behavioral blueprint for consistent agent operation, defining personality traits like helpful, friendly, professional, proactive, and transparent. These prompts teach the React pattern implementation with transparency, ensuring that users can understand and trust the agent's decision making process. Next, we will work on implementing capability guidelines that help the agent make smart tool selection decisions. This includes understanding when to use web search versus existing knowledge versus calculations, and implementing email protocols that require explicit confirmation before sending. These guidelines ensure that the agent behaves appropriately across different scenarios and maintains consistent behavior patterns. We will work on implementing the core intelligence, the React pattern. This involves creating the four-step cycle: reason, plan, approach, act, use tools, observe, analyze results, and respond, provide comprehensive answers. This creates a transparent thinking process that users can understand and trust, and serves as the foundation for all advanced agentic AI capabilities. After that, we will work on enabling multi step problem solving with tool coordination. The agent can recover from errors by observing results and adjusting its approach, and iterative reasoning handles complex problems that go beyond single responses. This is what transforms our agent from a simple question answering system into a capable problem solving assistant. We will work on implementing sophisticated coordination that allows our agent to use multiple tools in sequence or combination to solve complex problems. The agent learns to decide which tools to use based on context and requirements, and manages scenarios where multiple approaches are possible. This coordination is essential for handling real world problems that require multiple steps and different types of information or capabilities. Next, we will work on handling tool dependencies and execution order management. This includes integrating results from multiple sources into coherent responses and implementing graceful recovery when tools fail or return unexpected results. This ensures that complex multi step processes remain reliable and produce useful outcomes even when individual components encounter problems. We will work on implementing the communication layer with OpenAI's language models. This includes message formatting for OpenAI API requirements and conversation context management for multi turn interactions. Integration is what enables our agent to leverage the reasoning capabilities of large language models while maintaining the structure and capabilities we've built. Finally, for this module, we will work on implementing function calling that enables the LLM to request tool usage with parameters. This includes tool schema provision, so the LLM knows how to call functions, and response processing to determine next actions in the reasoning loop. Function calling is what bridges the gap between the LLM's reasoning and our tool system's capabilities. We will work on creating a professional command line interface that makes our sophisticated agent accessible to users. This includes implementing argument passing for both single commands and interactive conversation, and support for both one off queries and ongoing conversations. The interface needs to feel responsive and professional while providing access to all the powerful capabilities we've built. Next, we will work on implementing rich text formatting with colors, tables, and progress indicators. We will also add user input validation and helpful command documentation to create a responsive interface that feels professional and intuitive. This transforms our technical agent into a polished tool that users actually want to interact with. We will work on implementing comprehensive error handling throughout the interface layer. This includes translating technical errors into user friendly messages and preventing cryptic error messages that frustrate users. Good error handling maintains user confidence and helps them understand how to resolve problems or work around limitations. After that, we will work on providing actionable feedback when things go wrong. The agent learns to maintain a helpful attitude even when the system cannot complete tasks, and suggests alternatives when primary approaches fail. This ensures that users have a positive experience even when the system encounters limitations or errors. We will work on testing our complete system end to end with all components working together. This includes validating memory management, tool orchestration, and error handling in integrated scenarios with comprehensive validation before deployment. Integration testing is critical because it reveals issues that only appear when all components work together in real world scenarios. Next, we will work on testing various user scenarios and real world usage patterns. We will ensure our agent behaves reliably across different interaction types and identify integration issues that only appear when components interact in complex ways. This testing ensures that our agent is ready for actual use and can handle the unpredictable nature of real user interactions. We will work on production ready deployment with proper configuration management. This includes security validation and credential management and monitoring and logging setup for production operations. Production deployment requires different considerations in development, including security, reliability, and maintainability. Finally, we will work on performance optimization for responsive user experience. This includes creating documentation and user guides for deployment, resulting in a complete working personal assistant ready for real world use. This final step transforms your development project into a production ready system that can serve as the foundation for further development and real world application. By the end of these 4 modules and 16 labs, you will have built a complete personal assistant agent that demonstrates mastery of that secure configuration management and handling, API keys and sensitive data properly, intelligent memory systems, maintaining context across conversations and extensible tool architecture, adding new capabilities through standardized interfaces, safe code execution, implementing security first design principles, and React pattern implementation and creating transparent, multi-step reasoning, one professional user interfaces making complex systems accessible, error handling excellence, providing graceful failure management, and system integration, combining multiple components into cohesive solutions. This hands-on experience will give you practical skills in AI engineering, secure software development, and system architecture that are directly applicable to professional AI development roles. Let's begin this exciting journey of building intelligence from the ground up